So here's an example of how to add 4 vectors, and I'm going to use 2 different methods. One's a simple graphical addition method, just to get a quick estimate, and the second is using vector decomposition to formally add these 4 vectors together, then recompose it to a single vector. So our first method, what we'll do is we'll start with pulling each one of these down and connecting them together, tip to tail, over and over again until we get to a final ending point. And what I'll do is when I pull these down, I want to try to draw these at the exact same length with the exact same direction. So let me sort of sketch my first vector in here. And that looks pretty parallel, so that length is about the same. And I'm just using my fingers here to make maybe a bit of an adjustment on the overall length of this. And let me switch this over to black. And so here's my first vector. My second vector is in red, and so I'm going to try to sketch that one in so that it's about parallel and about the same length. And I'm just using my fingers here to get a rough estimate of my length. It's about 2 hand spans. But this one needs to be stretched out a bit here. All right, so there's vector B. Notice I started at the end of the last one to do this and ended up over here. Vector C, this is easy because it's only up and down. So I'm going to pick up where I left off here. And I'm going to just measure with my fingers to see how far it is. And it's about that long. And just double check my length. It's about right. And my final vector is this green one. So we'll show it a green. And this is another easy one because it's moving directly to the left. And it's about 1 span with my hand over. So it's about right there to the left. And so what's my total? My total is going to be, I'll draw this in purple, from my starting point over to my ending point. All right, so my total should be about right there. And if I sort of look, this is a bit more than halfway, so maybe it's 50 degrees. And then the length from here to here, I'm going to compare it maybe to this length. This length is 20, which is a 1 hand span. This length is a chunk less than that. Maybe this is 18 newtons long. So it looks like I'm, in polar notation, it looks like I'm about 18 newtons long for my sum. And it looks like I'm at about a negative 50 degree angle from horizontal. So that's just a quick estimate. And that's all I'm doing with that. It's just to show that I can actually come up with a really quick estimate to see what's happening when I'm add multiple vectors using this graphical method. So let's go over and see what the math looks like behind this. So what I need to do is break each one of these vectors down into its x and y components. For example, on my A vector, here's A in the x direction to the left, and A in the y is upward. In my B vector, I'm right several units, and I'm down several units. All right, and so this is the methodology used. The nice C and D are easy because they're only in the y in case of C and only in the x in case of D, so they're going to be easy to work out. And what I need to do is find these lengths, and I'm just using SOHCAHTOA to do this. This is based on my opposite and adjacent. This one, my 55-degree angle is with respect to vertical, and so this is my opposite, and this is my adjacent side. So let's go ahead and add these up. So I'm just going to go vector by vector here. I'll start with vector A, which is, I'm just going to write this in polar notation first, just so we can see examples of each type of vector notation. So I'm 30 units long, and as a standard angle, a standard angle would be from there to there, from positive x-axis over. I'm 110 degrees, and I'll break that down. And I'll break that down now into its x and y components. So from a standard angle standpoint, I've got 30 newtons times cosine of 110 degrees will get me my x component. And the nice thing about a standard angle, it'll also take care of the sine for me, plus or minus sine. And I've got 30 sine 110 degrees. And when I work that out, I get negative 10.3 newtons in the x direction, and I get positive 28.2 in the y direction. For vector B, I'll do similar, but I'll use my 55-degree reference angle. I'll stick with that. And you notice that's with respect to vertical rather than horizontal. So my sine and my cosine, you got to be careful which you use. So I'm, in terms of its magnitude and direction, I'm 50 units long, and I'll put in 55 degrees with respect to vertical, just as a note to myself. And when I break this down, I'm going to get, for this y piece, this is in relation to the opposite. So I'm going to use, for the x-coordinate, I'm going to use sine to get the opposite side. So I get 55, whoops, sorry. I've got 50 units times sine of 55 degrees to get my x component. And then my adjacent side is going to pick up my y component. And this is a negative. I got to put my signs in here because I'm not using standard angles, so I have to put my own signs in. Get 50 cosine of 55 degrees. And when I work that out, I get positive 41.0 and negative 28.7. And these are underneath. Vector C is easy. In terms of standard, sort of a polar notation, a length and an angle, magnitude, direction. So I've got 15 units long, and my direction is at 270 degrees, and this is a standard angle. This is a standard angle up here as well. And of course, in terms of my x-y coordinates, this is easy because I have no x-coordinate, and my y-coordinate is negative 15 units. And D is just as easy. D is 20 units long. This is magnitude, and its direction is 180 degrees. That's a standard. I'll put a note down below as a standard angle. And once again, no calculator required for this because it's all negative x direction. So I've got negative 20 units in the x, and I've got 0 units in the y. And the units we're using on these are not newtons. I just picked sort of a generic U for units. All right, to find the sum, I just got to add these up. And so when I add up, I'm going to take the sum of my x's and sum of the y's. All right. And so my total x values turn out to be positive 10.7, and in the y is negative 15.5. That puts us in. If you look at the quadrant we're in here, we're right and down. So this is in quadrant 4, which we've predicted on our original estimate. And this is in rectangular notation. And I want to switch my answer back into polar. So to go to polar, I've got to take these two legs of a right triangle and use Pythagorean theorem to put them back together to the hypotenuse. So I got 10.7 squared plus 15.5 squared is my magnitude. And then my direction, I'll use inverse tan. I'll use the y value over the x value. And when you crank those numbers out, you end up getting 18.8 units long, and your angle is negative 55 degrees. All right. So that's my solution. That's my sum. Let's go back and check our estimate from the prior page and see if we were close. So I have 18.8 units at negative 55 degrees. That's relative to horizontal, or negative standard angle. And, hey, we're pretty close. We're 18 units long, negative 50 degrees. So that gives me confidence. This quick little estimate gives you confidence that all my detailed work on the next page is most likely right. And that's how you do it.